The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. Thank you for joining us for today's webinar, Hazmat Series Part 6, Non-Accidental Release, brought to you by the Shortline Safety Institute and the American Shortline and Regional Railroad Association. My name is Sabrina Weiss. I'm the Vice President of Education and Business Services for the association. And before we begin, I want to let everyone know that we are recording this webinar and we will make the recording available to participants so you may go back and review anything that we discussed today. To ensure quality audio for the recording, all attendees are on mute and you will only be able to hear our presenters speaking. If you have questions during the presentation, you may type them into the questions bar on your screen and we will read through all the submitted questions at the end of the webinar. I want to thank today's speaker, Mel Massaro, Radioactive and Hazardous Materials Safety Specialist with the U.S. Department of Transportation, Federal Railroad Administration. Mel is on the line with me now, and you can see his slides on your screen, so I'm going to turn things over to him to get us started. So Mel, you can take it away.
All right. Thank you for your invitation, Sabrina. What I'm going to go over is a FRA's Hazardous Material Division's program to reduce NARs, non-accidental releases. The FRA's Hazardous Material Division's goal is 0 NARs. The Hazardous Material Division is graded by Congress on the reduction of NARs. It's called the Government Performance Result Act, or GPRA goal, and our goal is reduction of NARs. Since 1996, at a high of 1,241 NARs were recorded, and as of 2014, from the AAR and FRA statistics, we are down to 634. Which is good, but we've sort of stagnated. So we redesigned our protocol on what we're going to do with our inspectors to further reduce the NARs in transportation. On non-pressure tank cars, the preponderance of the NARs are from our service equipment, and primarily on general service cars, the Manway area. As you can see, there was 238 NARs related to the Manway, 101 NARs to the liquid line or vapor line. Bottom outlet valve was 88, although it's not top operating equipment, it's still part of the NARs, additional NARs in transportation. The vacuum relief valve was 48. Vapor line 34, pressure relief valve 27, safety event 18, and others and below are a very small percentage of the NARs. Around the Manway area in the causals, 120 of those causes at the Manway were loose bolts. 60 of them gasket deterioration. 25 gaskets missing, 19 gaskets misaligned, 3 gaskets the wrong size, and 3 of them had new breaks in the eye bolts to connect the Manway cover to the nozzle. Our approach to reducing these NARs is going into the shippers with our inspectors. And we're looking at 3 different areas that directly affect package preparation and reducing NARs. First of all, it's function-specific training. All shippers are required to provide training to all their employees preparing a tank car for transportation, and they have to come up with a training program that will not allow leaks in transportation. So we look at their specific training. We also look at their standard operating procedures, or SOPs, and their owner equipment manufacturer OEM recommendations. Now, the SOPs and the OEMs are not required by regulation. Although when we find that they're not following a manufacturer's recommendation and they get a leak in transportation, we're going to ask for the maximum penalty because they did not follow a guideline or an industry standard that was out there to help ensure that that package is secured according to the item they're using, such as a gasket. Now finally, after reviewing those training items and their SOPs and OEMs, we go out to the loading racks where the operators are loading the cars and observe them to see if they're following their training procedures or any SOPs or OEMs. So as I said, what we do, we first of all go over the training inside the office, and we look at their SOPs and OEMs, and finally, again, out to the loading racks and watch how they prepare a tank car for transportation. This slide here just goes over some general nomenclature for a general service tank car. On the top is your protective housing, which holds all your service equipment. This is the newer design car with roll protection to protect the service equipment instead of the old stuffing box. And you'll see a couple of photographs later of the old style stuffing box. On the left-hand side, you'll see this new design tank car has a half head shield for impact and a derailment to protect from a puncture into the head shield of the head of the tank car. And of course, you're reporting the marks, your car number, your bottom outlet valve at the bottom of the car. On the other end of the car, you'll see at the top the DOT specification. That DOT 111A100W1 is the type of car which is important to how what type of commodity is allowed to be loaded in that car. So the shipper will have to look at that, make sure to go to the chemical they're going to load in the car, go to the CFR, and see if that car is acceptable for the commodity that they're going to load in the car. The other very important item is the qualification stencil. That lets you know when the service equipment was last inspected and when it's due for re-inspection, whether it has a lining it needs inspected, when it was installed, or the tank shell qualification itself. If any of those are out of date, that car cannot be loaded. This next slide shows the protective housing and the service equipment under that protective housing. You have the pressure relief device, the vapor line valve, the liquid line valve, and the vacuum relief device. The pressure relief device is designed that if you build up too much internal pressure rather than split a car, it'll let the commodity and vent the product to stop the car from bursting. The vapor line or the vapor line is used when you're loading a car. As you're putting product in a car, you have to be able to vent the car because you're displacing the air, unless you're loading through a manway cover. But if you're loading through the service equipment, you have the vapor line and the liquid line. And the liquid line, of course, is where you hook up your loading line and start loading your car. The vacuum relief device is designed for the unloading side of the house. After the car is loaded, it goes to a customer for unloading. If the unloader doesn't open a vapor line valve to allow in air as the car is unloaded, the vapor line is designed to suck air in to stop a car from collapsing. And they'll collapse like a tin can if you don't have air going into your car as you're unloading it. At the bottom of the car, this is the bottom outlet valve, and at the top there you see the bottom outlet valve handle, which actuates your valve to open or close your bottom outlet valve. And at the bottom of the configuration, you'll see the bottom outlet cap, which screws onto your valve, onto the nozzle off the valve, and at the bottom of that is a bottom outlet valve cap. These are items that are found leaking in transportation quite often. If you remember back to the earlier slide, 88 of the NARs were from the bottom outlet area. Generally, it's from the cap and a bad seal. Prior to loading a car at a loading rack, the shippers should be doing an inspection of the car of all the service equipment. As we identified, you look at the test dates on the service equipment, make sure it's the right car. The other items you look at are the vacuum relief valve. Is the valve bending? Is it in proper condition? Has it been disabled? We found that people, when they think it's not working, they'll get duct tape, wrap around it, and prevent the valve from hissing. You're disabling the function of that car and could cause a collapse of that car. The other things we're looking at is the vapor and liquid lines to see if the caps the plugs are tight, the valves are closed. And if you see the picture on the left here shows you the old bread box cover for the liquid and vapor lines. The loader has to look at these valves to make sure they're in operating condition before loading a car. Another thing they'll look at, if they're loading through the manway cover, they'll open the manway cover and check the gasket. In this case, that gasket is torn. And the cause for this was generally it's over torquing. And we'll get into that in a little bit. Most of the time it's caused by pneumatic impact wrenches. Prior to the last 10 years, most of the industry was using pipe wrenches to torque down the swing bolts or the eye bolts on a manway cover. In the last particularly 10 years, 5 years especially, they're going to impact wrenches. It speeds up the operation, but we'll get into the problems with that in a few slides here. One of the things they're inspecting for is that gasket. This type of gasket is sealed, instead of on the nozzle of the manway, is right in the manway cover. This is a hard gasket, and it has a compression set. On the left, on the right, you'll see that there's a little groove inside that gasket. That's not supposed to be there. It's lost its elasticity and will not give you a good seal. And if you would look up the use for most gaskets, not all, but most gaskets are a one-time use gasket. In order to save money, we'll find that shippers will reuse gaskets over and over. And this is a result of reusing a gasket. You get a permanent compression set. Then when you go to torque your manway cover down, it's not going to seal. This gasket's a rubber or elastomeric gasket. It is a multi-use gasket, but over time it will get degradation. As you can see there, it's starting to rot away, either from chemical degradation or from the age of the gasket itself. Prior to loading a car, the loaders at the rack have to identify if there's any, what we call a heel in the car, any commodity left at the bottom that wasn't emptied from the last shipment. This person here is taking a mechanical estimate of the heel in the car. They'll stick a rod down like this, they'll come up, they'll know how much commodity is in the car, and then they'll figure that out for what's called an outage. When you load a tank car, the federal regulation requires anywhere from a 1 to a 5% outage depending on commodity. So what heel's in there has to be calculated in how much you put in a car. So you have that outage at the end. Prior to loading that car, there's manway inspection areas. The FRA got together with the renewable fuels industry, and this is a couple of slides from that, identifying areas that have to be inspected and careful attention to before loading a tank car. As I mentioned before, you inspect the manway cover, and on the cover, what you're looking for, if the gasket is a gasket that's on the nozzle, which is the blue at the bottom, At the top, you want to make sure that groove is free of any debris or not cut or a pathway. If there's any cut in that or a gouge, you won't get a good seal and you can get a leak area. The other thing you're looking at is your eye bolts to make sure they're in proper condition. You inspect your Manway nozzle, again, for any debris on it or any cuts, gouges, grooves, which could cause a leak path. The other thing you're looking at is the hinge pins on the swing bolt to make sure they're in good condition. There's another shot of the Manway nozzle surface to make sure the surface is clean and free of any gouges or cuts. Here it's showing an inspection of the Manway gasket, the pipe that goes in the Manway cover itself. You go around, you feel, you observe it with your eyes, also with your fingers. You feel around to make sure there's no compression set in it. And another critical part of sealing a car is your swing bolt. When you're sealing up the car, you have to make sure the swing bolt is perpendicular to the Manway cover. The eye bolts don't have any damage, any wear, and we'll show you some pictures of some wear. And like I said, they have to be perpendicular before fastening down. Another very important and critical part of closing a car is lubrication. We find many shippers are not using lubrication, and what you're doing, you end up galding these swing bolts or eye bolts on the car. So not only the threads of your swing bolts have to be lubricated, but as you see here, the face of the washer, very critical in the sealing of a Manway cover. Most OEMs or equipment manufacturers recommend the use of a torque wrench, so you are precise on how you're sealing your car. It's not a regulation, it's just a recommendation. This slide here shows you a 6 and an 8 bolt Manway cover and the sequence in which you secure a Manway cover. It's much like you do on a car when you change a tire on a car. It's in a star pattern. You go from 1 to 2 to 3 to 4, and it's done in 3 increments that I'll show you in the next slide. This is a gasket manufacturer's OEM. This is their recommendations for using their gaskets for sealing that Manway cover. And if you note there, I have a little note there that says, do not reuse old gaskets. Most shippers do not go as far to get the OEMs from the gasket manufacturer that they're using. One of the things we do when we're in there, we find out what gasket they're using. We'll look up the manufacturer's OEM, pull it up, and we'll go through the OEM guidance sheet and explain to them what's on it and why they should be following it. And right, it's clear in this one where it shows you, do not reuse the gasket. It's a one-time use gasket. Next, it'll show you the lubrication that we went over that's essential to the sealing of a Manway cover. And you do it in 3 equal increments, a 36 being a final torque. Your first round, 33%. 30%, your second round is 66%, and then your final torque at 100%. You let that sit for 24 hours, don't go back and retighten it with this sequence. You could have a leak path in your nozzle area. These slides are looking at Manway swing bolts and the defect. What we're illustrating here, every Manway gasket, a Manway cover, has a safety eye bolt, at least one, most have two. What that's designed for, when the car is under load, it will build up pressure in transportation. And when it's going to your consignee to be unloaded, they'll loosen the swing bolts, flip them off to the side, but there's two safety eye bolts, one or two, and if a safety eye bolt's not in place, and they loosen that, that Manway lid will fly off. Even under 5 to 10 pound pressure, it'll fly off like a rocket, and it could really hurt somebody or kill them. So there's a safety swing bolt that has to be there. This is an illustration where that swing bolt, the safety swing bolt, is not in place. This is a safety swing bolt, and you can see the little pin that goes behind the little lug that comes down on the Manway cover. And off to the right, you'll see a safety swing bolt illustrated, a new one. So when that's loosened, there's no way that swing bolt can fly out and the Manway cover come up until that pressure is relieved. This is an illustration of a galded swing bolt. If you don't lubricate, and particularly with the use of pneumatic heat the metal, it is an awful lot in transportation. Prior to using impact wrenches, you didn't see this as much. So 15 years ago, 20 years ago, you didn't have a lot of this. Now we're seeing a tremendous amount of galded bolts. This slide is illustrating where they didn't lubricate the washer. Remember, a few slides back I said you have to lubricate the face of the washer. Well, using an impact wrench and not lubricating, you're cutting that washer down, and that washer is cut probably about 40% through. Now, when that washer is cut like that, you're not getting an effective load bearing across that surface of that Manway cover. The swing bolt on the right in this illustration, there has to be some kind of mechanical stop at the top of that swing bolt so the nut doesn't back the whole way off. The problem with a nut backing the whole way off, there's a top and a bottom to a nut. And if you have it on incorrectly, it's going to tear up your washer on your swing bolt assembly or eye bolt assembly. Now here it's showing two different defects on this Manway cover. One is the one on the right is showing the safety swing bolt in place that has the pin in. It's the correct safety swing bolt. Although what's happened after they torqued it so many times with an impact wrench, you've bent the lugs on the Manway cover to the point where you've also bent, you're not getting a seal on that Manway cover because you put that pin up, you pulled it up against it. The other defect on the left and right at the top, that mechanical stop at the top of the safety pin is missing of the swing pin. Here's another illustration of over torquing with impact wrenches on a Manway cover. You really deform that cover and you're not going to get a good seal. Industry standards and OEM recommendations that we found that have not been followed is swing bolt lubrication. Some people are taking a shortcut on their lubrication. Instead of using a recommended lubricant that the manufacturers recommend, they'll get like WD-40 and spray on there. Well, WD-40 is not a lubricant. In fact, it does just the opposite. And what it will lead to galding on the eye bolts. Another thing that we've noticed on our inspections is the bottom outlet caps. At one time, the Code of Federal Regulations required that the bottom outlet cap be removed while loading a car. And the reason for this is twofold. One, to make sure there's a gasket in that cap and it's in good condition. The other is to make sure that that bottom outlet valve is not leaking and the seal on that valve is in good condition. That is not in the regulation anymore. It was removed. So now we're running into the phenomenon where we're shipping cars with bad outlet valves. And the problem with that is it gets to a shipper, a consignee, from a shipper to a consignee. The unloader removes that bottom outlet, product starts running out of the car, gets all over him, and we can have a critical error. Human life could be involved. We've had cars that we lost a whole load on people. We had cars that were elevated temperature with more than 200 degrees, people getting scalded. We are recommending to the shippers that they do remove the bottom outlet caps, even though it's not required by regulation. Manway cover securement is another big issue. They're not following the OEMs to the gasket manufacturers. Storage in your manway gaskets. A lot of times we'll go onto a shipper's loading rack, and we'll see the manway covered gaskets hanging by a pin on the side of a railing or something. Well, when you hang a gasket like that, it deforms it, and then when you go to use it in a car, you're going to have a leak path automatically. When people are using torque wrenches, as we would prefer that they do, we're finding out that they're not calibrating those torque wrenches. And torque wrenches are very sensitive to how you handle them. If you drop them, you really should retorque them. In the tank car repair and building industry, we do have regulation, and one of the things is required is those torque wrenches have to be calibrated daily. Now, we don't expect the shippers to do it daily, but we do want them to have some kind of program for looking at the calibration routinely. Or if there's an incident when you drop a torque wrench, that you get it recalibrated, make sure it's within the specifications of the torque wrench. Another thing is lack of safe storage of the torque wrenches. Some people just lean them against a post or something. They could fall off the rack and get out of calibration. Other critical observations we found, manway covered gasket reuse. As I showed you in one of the illustrations prior to this, most gasket manufacturers only, for a hard gasket, only recommend one use, no reuse of that gasket. Now there are better gaskets, hard gaskets, that are designed for reuse. Of course, they're a lot more expensive and shippers tend to stay away from them. So we let the shippers know that these are one-use gaskets. We can't tell them not to use it, but there is a chance that the gasket could leak in transportation. What we do tell them, although we don't have, if they do have a leak in transportation and are not following a gasket manufacturer's recommendations, we are going to ask for the maximum penalty, because they willingly knew, once we tell them that there is a procedure or a recommendation and they're not following it, they decided not to follow that, so we're going to elevate the penalty amount. We're swinging over swing bolt washer lubrication, very important. Torque value sequence, which is the star pattern. And a big one is the 24-hour retightening of the manway cover swing bolts. We probably have less than 1% of the manufacturers retorquing or checking the retorques or retorquing after 24 hours. We're in a production era. Wrenches. A 3/4 impact wrench develops anywhere between 1/2 inch Now, hard gasket requires at max 200 to 250 foot-pounds. Well, with a 3/4 inch impact wrench, your first shot on it, you've exceeded that maximum torque value. And that should be acquired in 3 equal steps. In the 1/2 inch, you're a little closer, but still your sealing end at 700 is going to destroy a gasket. In the elastomeric or rubber gasket, the recommendations on that are generally between 90 and 110 foot-pounds. So you'll cut a gasket, you'll kill it real quick. And for the people still using pipe wrenches, we did a study with Union Tank Car, and we took an 18, 24, and 36-inch pipe wrench with a medium-built person, and we had them tighten the Manway cover in the proper sequence, and then we went back with a torque wrench to see what setting it was. And what we found is that an 18-inch pipe wrench will develop up to 140 foot-pounds. Well, if you go back to an elastomeric gasket at a maximum of 110 foot-pounds, we've already exceeded it and probably have pinched or cut that gasket. A 24-inch pipe wrench will develop up to 200 foot-pounds, which is probably ideal for a hard gasket. And a 36-inch pipe wrench will get you up to 250 foot-pounds. And this again, I just told you about the elastomeric and the hard gasket. The elastomeric maximum between 80 and 110 foot-pounds. The hard gasket anywhere between 200 and 250 foot-pounds, depending on the manufacturer. Shipper's responsibility is package inspection, which I went over a little bit of it in this slide presentation. Their outage, they're not allowed between, and depending on the product, anywhere between 1% and 5%, and package securement. If we eliminate just the top 5 causal factors, we will go a long way in reducing NARs. And like I say, most of them are in the Manway area. At this point, I'd like to hand it over back to Sabrina.
Great, Mel, thank you very, very much. That was very informative. You covered a lot of material here. I just want to let folks know, I know we had a couple of issues with the audio on a couple slides there. So if you had any trouble hearing the audio and you have questions, I would say go ahead and reach out to Michelle Malsky directly, and she'll make sure she can field those questions on Mel's behalf. If you have questions now for Mel, this is a reminder, you can type them into the questions panel on your screen, and we'll go through those now. While I wait for a couple of those to come in, I just want to let folks know that if you think of something afterwards and you want to reach out to Mel directly with a question or to discuss an issue, his contact information is up on your screen now. If you have any questions or feedback about webinars, in particular for the Shortline Safety Institute, Michelle Malsky's contact information is on your screen, and my contact information is also up there if you have any more general questions about webinars and such. So so feel free to reach out to anyone who's been on the webinar with your questions and for additional information. So one question that we have here is, how can we as a railroad prevent this, and how do we approach our customers?
That's a good question. The best way to prevent this is when your railroad crew goes in to pick up cars at industry. There are certain areas that they should be looking for from ground level. You're not required, and we don't want you climbing up on a tank car. But from ground level, if you can see the Manway cover swing bolts, are they up or down? Look at the bottom outlet valve. Do you see any drips, leaks, or anything that's non-conforming? Another thing that you should be looking for is the test date. That's required by regulation. So when you're looking at that car, are all the service equipment test dates in date? Another big thing we find is when you look at your shipping paper, compare If you can talk to your shippers, FRA will be glad to, we go in the shippers. If you want to get FRA inspectors and their carrier to go in and work with your customers, we will be glad to do so.
Great. Okay, another question we have, Mel, is were NARs tracked before 1996?
They were tracked, but they weren't tracked nationally. I think they were tracked by each individual carrier. I don't ever recall a national tracking before that date.
Okay. Okay. What is the difference between a non-pressurized and a pressurized tank car? And can a pressurized car have a non-accidental release?
A non-pressurized tank car usually has a manway cover. It'll have your fittings exposed, the bottom out. Could have a bottom outlet cap, and the maximum pressure on it's 100 foot-pounds, or 100 pounds per square inch maximum capability. Although that's not its burst pressure, but it's normally a 100-pound car. The other things it will have is a protective house of service equipment at the top. Now, a pressurized tank car is a different animal. It will not have a bottom outlet fitting, and yes, it can have an NAR. LPGs will. We've had them with anhydrous ammonia cars. We'll get some non-accidental releases. Generally, it's caused by overloading and not following the outage that I mentioned.
Okay. One more question we have here. What is the maximum penalty for reusing a gasket?
There's no maximum penalty for specific to a gas, but if we go to a shipper and we inform them of the gasket manufacturer's recommended practice, and then we find afterward that a car has leaked after we met them, because we have the inspectors document this on their inspection report. If we find an NAR in transportation, we will ask for a maximum penalty, which is up to $25,000.
Okay. Let's see this one. So Michelle Melsky, obviously with the Shortline Safety Institute, is here with me. So she may want to weigh in on answering this question in addition to you, Mel. The question is, human error on the caps when sealing or buttoning up on cars is a big concern. Who trains the customers? And does the Shortline Safety Institute have a PowerPoint to hand out to customers? So, Mel, I guess the first part of that, before we get to the PowerPoint handout, what's your thoughts on that?
Every shipper is responsible for the training. Where they get the training, we don't specify. Now, we do review their training procedures. There are lots of PowerPoint. The AAR puts one out, a good video on loading and unloading tank cars, and a real good reference. And part of our package preparation initiative, one of the things when we go in and we inspect a shipper and when they're not following a certain procedure that's not regulatory, is the AAR's pamphlet 34. The pamphlet 34 is a good reference guide on how to load or unload a tank car. So what we'll do, that AAR pamphlet 34, one example is, I mentioned in bottom outlet cap. At one time the regulation required that to be off during the loading. Well, now it's not. It was dropped from the regulation. But AAR pamphlet 34 recommends that cap be off till the car is loaded, so you can see if there's any leaking. So if we go into a shipper and see that the shipper does not remove the bottom outlet cap, which is not regulatory, we will note that and tell them that a industry standard recommends that you do for this reason, to see if it's the bottom outlet valve gasket in that cap that the short line could give to their customers also.
Yeah, and I just want to piggyback off what Mel was saying there too. You know, every shipper is responsible ultimately for the loading and unloading aspect of it, but there are some things, as Mel mentioned, that we can kind of be proactive with our crews with for checking, like the drips. If we see any leaks coming up from the top. There's a webinar that we did a few months ago about tank car inspections particularly, so that would be a good one to just review with not only your crews and your people in the field, but to see what to be looking for at industries. But it could be also a good refresher for you and your customers to sit down and have that talk and have foster that relationship with your customers and say, hey, my guys are going to be looking for this too. I hope we have a good mutual understanding here. And as Mel mentioned, the pamphlet 34 is a great reference. We'll be sure to get the resources for that. And that's a great idea to have even potentially another webinar about approaching your customers about some of these topics. And the training is up to the customers, how they want to train their people. However, how we approach our customers and tell them the importance of safety and the inspections from our point of view from the railroad might be a very great idea for us to consider for a future webinar, as well as a future handout to be giving and helping everybody out in our industry. So we'll certainly be working on that, and thank you for that suggestion and comment.
Excellent.
Sabrina, I'd also like to add to that please do work with your hazardous material FRA hazmat inspector. They'll be glad to work with you and maybe go in with your shipper. I mean, we should work as a team, all of us.
Absolutely.
Great. I think that's really helpful. I think a follow-up question to this is, where would someone find the pamphlet 44? So are you going to reach out to AAR for that, Michelle, and we'll see if we can maybe post it with our materials. I don't know if that's something we can post. If it is, we certainly will, and if not, I guess folks should go directly to the AAR and see if they can get it.
We'll try to redirect that link at least if we can't directly post it.
Great. That's a good idea. Okay.
Yeah, that's AAR pamphlet 34, and it's available online.
Great. Yeah, then we can try and link to it. When we put the recording of this webinar up on the Shoreline Safety Institute website, we provide a link to the recorded webinar. We'll also provide a link to that pamphlet if we can do that online. So look for it there. But I guess you could probably also check out the AAR website and see if you can access it directly. If we don't have any other questions, Mel, did you have any sort of final words that you wanted to share with folks here?
I'd like to thank you for asking me to do this, and I am sincere in working with the railroads. Reach out to us. We will work with you. Our goal is to reduce these NARs. You don't want them on your railroad, and like I say, we are judged by Congress on reducing NARs. We are serious about it. Great.
I think that's a really positive note to end it on, that it's about everybody working together. So so on that, I remind folks, you've got Mel's contact information here. It will also be included in the recording, so please don't hesitate to reach out to him directly if you have questions, or Michelle or me if there's anything we can do for you specifically related to webinars. Mel, thank you very much again for doing the webinar for us today. I think this is a lot of great information to everyone. I hope everybody found it educational, and we'll be sending out the link in the next couple of days if you want to share it with any of your colleagues. We will have, I believe right now we've got 3 webinars scheduled for December. We're getting those set up now, so check back the website in the next couple of days, and those should be up and you'll be able to register online. So until then, everybody have a great afternoon. Thank you so much for joining us.